When solving two-step equations, why do we always start with the addition and subtraction step? The short answer to this question is because it's easier. In math, there are an infinite number of ways to solve problems. What we want to do is be clever and find the simplest, easiest way that is going to be quick and make it easy for us to not make errors. In this example, we have 2x plus 1 equals 7. This means 2 times x plus 1 is 7. We always start by drawing a line through our equal sign. Ultimately, we want x equals something. What I said in a previous video is that when you're eliminating these numbers to isolate x, here we have multiplying by 2, 2x is times 2, and adding 1. I had said deal with the addition and subtraction first and eliminate the 1. In this example, however, we're going to show what happens if you deal with the multiplication and division piece first. So, the inverse of multiplying by 2 is dividing by 2. And what we do to one side of the equal sign, we must do to the other to maintain equality. Now, this is what most people are going to do. However, it's not correct. It's a very common error. When we are solving equations, what we do to one side, we must do to the whole side. So we can't just divide 2x by 2. We would have to divide 1 by 2 as well. So what this should have looked like is this. Now, instead of being able to easily just eliminate this 2 divided by 2, we have to deal with this as well. This means we're going to end up separating fractions. So 2x plus 1 over 2 is the same thing as 2x over 2 plus 1 over 2. On the right side of the equal sign, we have 7 over 2. We've maintained equality. Now we can go over here and see that 2x divided by 2, well, 2 divided by 2 is just 1. That's going to give us 1x left over. We can bring that, well, I guess we're going to have to erase this. We already have no room left. So back here, we have x left over plus 1/2 equals 7 over 2. Next thing, we need to eliminate this plus 1/2. The inverse of plus is minus or subtract, so we're going to subtract 1/2 from each side of the equation. We see that 1/2 minus 1/2 is 0. We have x left over on the equals on the left side of the equal sign. And then over here, 7/2 minus 1/2 equals 6/2. Now, we've gotten our final answer, but we see that we have a fraction we need to reduce. So x equals 6 over 2 is the same thing as x equals 3, which would be our final answer. Now we'll show our other method. Separate the left and right side of our equation. At the very end, we want to isolate x to have x equals something. Here we have multiplying by 2. Here we have adding 1. Let's start with eliminating the plus 1. The inverse of plus 1 is minus 1. We'll subtract 1 from both sides of the equation. 1 minus 1 is 0. What we have left over is 2x equals 7 minus 1 is 6. Now, all we need to eliminate is the 2. This means multiplying by 2. The inverse of multiplication is division. We're going to divide both sides by 2. 2 divided by 2 is 1. That gives us 1x left over. And 6 divided by 2 is 3. Notice, we got the same answer to both sides, right? Two different methods of solving the same equation, providing us the same answer. However, this one is longer and messier. We're getting into adding and subtracting fractions, which is much more difficult than simply eliminating this and then having a quick, simple division. So, this is why we're going to start with any addition and subtraction step before any multiplication and division step.